To work on adding and subtracting decimal numbers, we started off first with money amounts, so going up to the hundredths. So for this question, 36 and 54 hundredths plus 41 and 24 hundredths, we used both mental math and hundredths charts to solve. So for example, we took care of the whole numbers first. So we did the 36 plus the 41, and all students can do that mentally, and they get 77. We have a bunch of different addition strategies that we've already been working on in class. To take care of the decimal portion of the number, we did something a little bit differently. So we took the 54 hundredths from this question. I tried to color code it so it makes it easier to follow with me. And I colored in 54 hundredths on the chart. So then I needed to color in 24 hundredths as well. So I've done that with green already. And I can show you by putting it onto the hundredths chart. And you can see that all together, if you look at all the parts that are colored in, it would be 78 hundredths. So the full sum then would be 77 and 78 hundredths. Next, for subtraction, we did very much the same thing. So here, if the number is 7 and 86 hundredths, and we're taking away 5 and 34 hundredths, again, we took care of the whole numbers just by using mental math, like knowing 7 take away 5 is 2. And then for the decimal portion, again, we used a hundredths chart. So for this question, I colored in 86 hundredths on the hundredths chart, and then I wanted to take away 34. So normally in class, it actually looked a little bit more like we just colored it in with X's. But here I'm trying to show you that basically what we did was take away from the first 86,000 or hundredths that we had. I took away 34 hundredths from it. And then we're left with 10, 20, 30, 40, 52 hundredths. So our final difference then would be 2 and 52 hundredths. Now the students very quickly realized that we can do this just using the plain old algorithm like we have for whole numbers before. So the only trick to decimals with the algorithm is making sure that your decimals are lined up. So for this question, for example, we can do 2 plus 5 is 7. 7 plus 0, still 7. 6 plus 4 is 10. Remembering that we put the 0 down, we carry the 1 up. So now we have 6 plus 2 plus 1 is 9. And 4 plus 3 is 7. And the only thing we can't forget is to put that decimal point in. When we go to subtraction and we use the algorithm, same idea for subtracting as well, except the only difference, and the same thing you could also be doing in addition to, is if you don't have an equal number of decimal points or decimal places, sorry. So for example, here we go up to the thousands, and here we only go up to the hundredths. This is when you need to put that magic 0 placeholder back in. So for example, I want it to look the same, just like we did when we were comparing decimal numbers. We're going to make sure that it's the same so that it's easier for the students to subtract. So when I go to subtract this one, I take 3 from 0, or 0 from 3, sorry, and I end up with 3. I can't take 6 from 0, but I can certainly take 6 from 10, so I'm going to borrow and make this a 10. So 10 take away 6 is 4. Once again, I can't take 7 from 4, but I can borrow from the next place. This becomes an 8. This is 14. 14 take away 7 is 7. 8 take away 4 is 4. And just remember to put in your decimal point.